for this. So yeah, we can start by Luis Eduardo Montes.
Hey, hello.
Yeah, you can go ahead. You can share your screen.
Okay, can you see it?
Yes, we can see it.
Cool. Okay. So hello everyone. So I'm going to talk to you about PolarDB serverless. So it is a cloud native database for disaggregated data centers. So first, let's see what is a serverless database, right? So the main goal in serverless databases is to provision on-demand resources based on the current workload, similar way to serverless functions, right? But now applied to databases. So which features serverless databases offer? It is on-demand resource provisioning, like based on your workload, the database is going to increase the capacity or reduce it. Pay-as-you-go model, you only pay for the resources that you are consuming and the storage in your database. Auto-scaling, so that's what I was explaining, that it has to auto-scale depending on your workload, and auto-pause. So this means that if there is no traffic in your database, then your database has to shut down, and it is only to cost you the storage that you are using at that point. So currently, the limitations that the serverless databases have, it is that the CPU and memory are tightly coupled. CPU and memory scale up and down simultaneously. This means that they increase the capacity or shrink it in a fixed unit. Like in the case of Aurora, for example, for Amazon, it is Aurora capacity units, and it is 2 gigabytes of memory, for example, and CPU. And other problem is that when the outpost happens, the database releases all the resources. So yeah, it takes some time to reallocate the resources that you released. Sorry. So we have some databases design, right? One is the monolithic design. That is one that probably many of us are aware of, where we have a server and it contains the CPU, the memory, storage, all in the same server, right? And we can have replicas to keep backups. And then there is another approach, which is the separation of compute and storage. This is a different design, and I think this is the design that all the vendor providers uses for the serverless databases. So basically, you have CPU and memory, and you can have, in the first example, we can have a disk, and then that disk is in a different server, probably it is in a different machine, and then you can attach it to your CPU. And then there is another approach where you have storage, and that same storage is shared between CPUs. So these are the 2 different approaches, and yeah, some problem with this is that it is difficult to allocate new resources for the monolithic design, for example, or yeah. So what PolarDB proposes is the next. So PolarDB serverless is a cloud-native database implementation that follows the disaggregation architecture. And what is disaggregation architecture? Well, disaggregation design, it is basically disaggregation design. The design is basically where all your components, your hardware components, are separated. In this case, CPU, storage, and memory. All of them are considered nodes in your network, and they can be in different racks and different servers, but all of them can be connected using high-speed networks and technologies like remote direct access memory. So one advantage of this is that the resources are not tightly coupled, and yeah, I mean, you can scale, for example, if you just need memory, then you can scale just memory. If you need more CPU, then only CPU is increased. Okay, so this is how PolarDB, this is the design for PolarDB. They follow this kind of design, disaggregated design. Other advantage is that the memory can be shared between multiple processes. So basically, all CPUs can see the same memory. So that's an advantage. So how does PolarDB serverless work? So basically, all the PolarDB serverless include one primary node, multiple read nodes. Each node contains the SQL processor, the transaction engine, and buffer pools. So there is a proxy node for load balancing, and in the file system, it also includes PolarFS. We talked about PolarFS in the previous class, and also it has remote memory pool as an addition. So how it works? So basically, I'm going to try to explain how it works in little words. So we can see here like the presentation, right? The first is that the write node flushes all the redo logs, right? Redo logs records to PolarFS. Redo records are basically operations that have happened in the database, and then the transaction is committed. Then the RW node broadcasts those messages to inform that, hey, the redo logs have been updated, and after that, the read-only nodes have to read all that new information from PolarFS. Then all the read-only nodes read that information and apply it to the buffer pool, to its own buffer pool, so that they have the same information between read-only nodes and write node. And then, the read-only node just confirms to the writing node that, hey, okay, I have completed to read the new logs, so I'm good. And then the write node just say, okay, so these logs are no longer required, so I'm just going to purge them because all the read-only nodes are already like have the information. So these are the steps for PolarDB, but not serverless. The difference with PolarDB serverless is that they use the memory, right? In this image, we don't see the memory resource pool, but unfortunately, there wasn't an image in the paper. But basically, what they say in the paper is that it is the same, but now they also add memory resource pool that can be shared between all the nodes, write and read nodes. So using the memory pool brings some challenges. For example, keep consistency between keep consistency, right? Because if the write node is writing, but all the nodes can read, maybe there could be some inconsistencies there. Then the latency, because everything is shared in the network, then there could be some issues, right? Because all the components are in the network, and it may take some time. They do not use HTTP, they use the RDMA technology, so it seems to be faster, but still it is network, right? You need to take care of that. And then the last thing is reliability. What happens if some of the nodes fail, right? So those are the three challenges that they are trying to solve in the paper. So the next is, okay, disaggregated memory. This is like the interesting piece, because this is the one that makes, or well, not makes, the difference between PolarDB regular database and serverless. So they use an API for the memory. So basically it is page register, unregister, read, write, and validate. So register, just as the name mentions, the write node writes like pages is like the basic structure in the database that contains the information, right? So it registers database pages, and then the read nodes also can register pages so that they can have information in its local cache. Then unregister does the contrary. The node unregister from the page. Read also reads information to local cache, writes information to the page, and invalidate. The invalidate is one operation that grants like consistency, will help us to get consistency between nodes. I'm going to talk a little bit more about it in the next slides. Okay, and the memory has like one important thing, right? Oh, sorry, again. The memory pool has like two classifications, a slab and a home node. A slab basically means that it is a node where you're going to save information about pages. A slab is just memory. It is 1 GB of memory, continuous, and yeah, it is used to get like the page. It is used to get the page that you want to access. So all the nodes, since the remote memory, well, since the pages are in the remote memory, all the nodes need to know how to access to which probably memory node and to which page, right? So the home node has this information, and it has like many data structures that they are used for that. Sorry, I kind of struggle here, but I hope you don't have questions. Okay, so this is the visual representation of these data structures that are in the home node. The home node, again, is just the memory, a remote memory node that where it starts like the first remote memory node. So here in the presentation, we see that, for example, the memory node is the number 15. It contains the first page array. A page array is just a continuous memory of 1 GB, and in each page can have 16 kilobytes of information. So we have the page address table, which is a table that contains the page ID, in which memory node ID it resides, the address for that page, how many nodes, like database nodes, are registered to that page, and the PIV. The PIV is I don't remember. Let me just go back. The PIV is the page invalidation bitmap that tells if the page has to be it is dirty, let's say, so that the nodes know that they need to read the information. So, okay, so this is how it looks. This was not in the paper. This is just how I think it is. I mean, it is my representation. I read the paper many times, and this is like a good example to explain that concept of page address table. So we have the page reference directory, which is also a table, hash table that has for each path entry, the path entry is this one, has like the list of the nodes that are registered to that page. For example, in this example, we see that the database node 1 and 2 are registered to the page 1, the node 3 and 2 are registered to 2, and so on, right? And the PLT is the page latch table that it's used also for consistency. I'm going to talk a little bit more about this later. Actually, in the next slide. And many of those structures are used for cache invalidation. So this is for, since every node has like a local cache, they need to know when an update is happening, right? So the process is like this. So the write node updates its local cache and calls page invalidate. So this happens when there is a transaction and there is an update, right, in the database. This function will set, page invalidate will set the corresponding bit in the PIV on the home node. The PIV is the bit that tells us if there is an update in the page. Then it will look in the page reference directory and we'll get the list of read-only nodes, and it is going to tell that, hey, your cache is no longer valid. You need to update that information for this page, right? And then, yeah, set the PIV to the read-only nodes. And yeah. So when that happens, the read-only nodes need to confirm to the writing node that they have received the instruction and that they have updated the cache, so that there is no like inconsistency between the writing node and the read-only node. So if there is a timeout, the database takes care of the read-only node and kicks off the node of the cluster, and so that this operation succeeds. So one other thing is the B-tree structural consistency. So how a database keeps the indexes is using a B+3, which is like a binary tree, but containing like more indexes. And one property is that the leaf nodes are already noded and are linked together, so you can access to them very quickly. But that's not the point. It was just a comment. And then, so if there is one update that is going to change like the structure of the tree, the writing node needs to lock those pages. For example, in this example, there is one operation, and SMO means a structure modification operation that is going to update the parent, and it is going to create two nodes, A prime and A double prime. And in order to prevent that, at the same time, a reading node reads like inconsistent indexes, right? Probably the writing node is writing in B, and the B node is already in B, but now what is it going to read, right? It is going to read A or A prime. So to prevent this scenario, PolarDB uses slogs for reading or xlogs for writing. So basically, the table that I showed before, the page latch table, keeps like which pages are locked with slogs or slogs or xlogs. So yeah, that's how the nodes know that there is an update happening. So they need to stop until the update happens, and so on. So one thing here is that PolarDB uses an optimistic approach. So it's going to try to update the SMO, assuming that everything is good. There is not going to be any modification structure. But if it detects that it is going to happen, then it rolls back all the changes and basically start from the beginning, right? And start locking all the pages that are going to be modified. And one other thing is the snapshot isolation. So snapshot isolation is basically just a version, right? When there is an operation, you can get one ID. And depending on that ID is the information visible in the table. For example, in this square, read-only node gets the ID of 12. And in this table, only the records with ID in the commit less than 12 are going to be returning that as part of that query. And since this is there could be a lot of like records. Probably some of those records are not updated yet with the commit. So that's when this other structure, the log data structure, comes in. So it is a combination, right? It keeps the transaction and the commit log. So the read-only node reads this table and also the log data structure to like confirm which are the records that need to be returned as part of that query. Okay, so this is pretty much it for the like consistency. These are many of the controls that they put in PolarDB. And other thing is about the reliability and failure recovery. So there are like unplanned node recovery for write nodes and planned, right? Basically, it is pretty much the same. So these are the steps. I'm not going to read them in this case, but basically, if the writing node fails, what happens is that the cluster manager, it will promote a read-only node, and the read-only node needs to take care of all the things, right? For example, collect the logs from PolarFS, from the storage, release PL logs, restructure all the active transactions, and then after all those checks and all those health checks happen, then it notifies to the cluster manager that, hey, okay, I'm good, I'm operational, so yeah, let's keep working. Let's accept requests. Other thing for reliability is the memory non-recovery, because as I mentioned before, the key piece here is the remote memory. So if it fails, then there has to be a way to recover that all the data structures that I talked about. And they have backups for the home node. And if regular node as lab node fails, then they just need to clear up all the data in all the metadata in the data structures. And the cluster recovery, it is when everything fails. So basically all the databases nodes and memory nodes start again from storage. They read all the information from storage, and the new writing node performs these steps again. So in terms of evaluation, so we can see here that, well, they measure many things. These are the ones that I thought they were more interesting. The throughput, for example, they say that if you have more memory in the remote, then we can perform more queries per second, right? That's the first one. The recovery time, this was for what happens for a planned crash and what happens for an unplanned crash. For the planned switch, it takes 6 seconds only to recover. And for an unplanned switch, it takes about 16 seconds to recover to create a new writing node, and then 7 seconds more to like keep to the performance that it was, right? To warm up more pages and make connections and all that. And the other things are for TCP/C and TCP/H. This, what I found is that they are benchmarks for databases. I do not know them how they work exactly, so I cannot talk too much about them. And basically what they say is that with more memory, I perform better, right? With less memory in the remote memory, then PolarDB, it is no serverless, works better because all the memory is in local memory, and it is not in the remote. And I think that's pretty much it. Yeah.
Thank you, Luis.
Okay, should I take the questions and answer part? Because I'm the discussion. Sorry.
Thank you, Luis, for the presentation. It reminds me a lot when you were talking about
sorry, I don't know if I am the only one, but I can barely hear you, Maddie.
Yeah, I
Yeah.
understand.
Can you hear me?
Very noisy
Not
and
very
loud.
well, yeah.
Is it better now?
Yeah, better.
Yes.
Okay. Yeah, I mean, I was telling this paper reminded me a lot about when in distributed system course, we were talking about concurrency control using two-phase locking and optimistic concurrency control that we were calling it OCC. I mean, very much similarity. Another interesting thing, this paper is coming from Alibaba, right? So,
Yes.
I don't know, do you notice anything special, or they're using different approach totally, or they're, I mean, I'm curious, did you see anything interesting?
Well, I really like that they try to explain all they use, but in 13, 16 pages, I don't remember, they cannot explain everything that they are doing, right? And it was kind of tough. I had to read it 3 times to understand everything that was happening. So yeah, I will answer your question. I couldn't compare what other vendors are doing. The difference here is that that they make made very clear is that they use the remote memory, and everything is disaggregated. That's not how the other vendors work. They use the storage, the shared storage, but not using the memory, the shared memory, remote shared memory.
True. Okay, I think Fernando prepared some
I have
questions.
I just have a question.
Yeah, go ahead, sure.
Yeah. I saw that in the deep dive you also talk about some Polar thing. And I think you said that,
It
right?
was Solas, no.
It was solar. Okay. Well, because I was thinking that maybe it was something related, and I wanted to know why you were researching about both of them. Yeah, but
No,
okay,
it's-
that's fine then.
Okay. This was very out of my comfort zone in topics because I don't have very experience in databases at all. I don't even a developer, but I did try to search a little bit in the web about this topic. And searching, I noticed, well, that a lot of people were discussing about how can I explain this? Like they were like comparing it with PolarDB with Amazon Aurora, C2's Analytic DB, Cassandra, and a lot of other services. But do you happen to know like really what are the differences between PolarDB and the other services? What are the advantages between other services? Right here. Well, hello.
Yeah, we will hear you. Yeah, at least on my end, I mean, I had never gone into like serverless databases that much. Only used Aurora a couple of times. The interesting part, it is like really the shared memory thing, and with the memory pool and all that, and how they really organize like the data structure for it to be kept. I believe Aurora doesn't do the same. Because they don't really exploit memory that much. They usually drop everything to disk. So yeah, I mean, it is very interesting. And I guess that more of this will continue appearing as technologies like that enable fast memory access and high-speed networks will continue appearing, right? I mean, there is we continue seeing tons of quick access RAM everywhere, right? And then eventually we will start seeing like quick access, basically solid state disks that in many cases work like comparably to RAMs, right? So yeah, I mean, it's very interesting to see this one popping up so often right now.
Have you used it? I mean, probably not, right? I mean,
No, only Aurora.
PolarDB.
No, PolarDB not at all. I mean, I don't even. Alibaba is like not a place for me.
Okay. I'm more in a business area, so normally I know companies only migrate or change their system where there is proof that these other technologies works better. So, is there any case of success of some companies using PolarDB, like probably Alibaba or something, but another one, or that you know? Probably not. Okay.
No, actually, that's something new for me.
It's very new. I mean, it's
No,
something.
no, no. I mean, for me, it's new. For me, it's new.
But PolarDB is new, right? I mean, it was released like in 2021 or just the paper?
I don't know. Probably it was already there. I mean, I was just checking an article about PolarDB being used in some places. This is not serverless PolarDB, I guess. It just only says PolarDB.
If this it is serverless, I think. So
no, yeah,
There are two flavors, serverless and not serverless.
Yeah, I mean, I was
If
just reading this one.
If you check PolarDB page, it says PolarDB was first released in September 2017 and was commercialized officially in April 2018.
Well, that's new, I think, right? 8 years.
Yeah.
When I was
For
But and this for the cases that I was seeing in this article, most of them are seeing like probably Chinese companies like Puhuai Technology and Shenzhen Fadada and KDCC. I don't know. I mean, probably there is. It would be really interesting to get someone that works in cloud in China.
yeah.
For us to know.
Yeah,
Like,
it's true.
yeah.
And you won't get nothing. Yeah, they don't share the secrets.
Yeah. Actually, when I was looking for this, I found a lot of pages that was in Chinese, and I was using Google Translator to try to understand. So thank you. Okay. And in other forums, I saw many people arguing that actually PolarDB, it wasn't really that good handling like how it's called disaster recovery times, but I don't have like other things in comparison. Do you know objectively if it's really good in that, or it's lack in another things if it's not that good? I mean, what are the disadvantages to use PolarDB between others? Basically, it's the opposite of the other question. It can be improved or something.
I'm trying to find like the comparison with other kind of serverless databases because yeah, even the paper said that, for example, full recovery for a write node was 23 seconds, and I think that's a huge time, right? So I want to compare if there is what is the recovery time for other serverless databases. So,
That would be really a hard question to answer. I mean, unless and until you have really, you're dominating like PolarDB, and then you're dominating other basically technologies, then you can really have a strong opinion on them. So I think that would be hard to answer.
Yeah. I have too much experience with databases, so if anyone has more in these kind of topics, feel free to help me to ask more deep questions about this.
Where is our hardware guy that is always around?
Yeah, actually, when I saw Luis suggesting this paper, I just liked it because it's from totally like different approach, different part of the world. And I thought it would be nice to see how, I mean, their approach also. But anyway, it's Alibaba Cloud is one of the biggest in the world, and you can't deny that.
It would be like a very interesting experiment that if we were like to, in another iteration of this course, like to divide ourselves into like some taking AWS courses, some taking Azure, and some going into Alibaba. And you know, I mean, maybe at the end we figure out they get hired before any of us, right?
Yeah, true. True. Any other questions? No. Okay, I'm trying to keep them short too, so we can have time basically for all the other presentation. And basically we can go now directly with the second presentation. Then we would have like a 10 minutes break between these two presentations with the last two presentations. Then we can have like 5 minutes to do with so much, a lot of distraction. So thank you. Thank you so much, Luis. Thanks, Fernando. I mean, I get it. It's not your things, and I appreciate you search around and you try to come up with the questions. So yeah, David, you can go ahead and share your screen.
Yeah, sure. Can you see it now?
Yes, yes.
Okay. I'm going to talk about vehicular edge computing. So let's get started. Imagine the case that you are driving in a congested avenue. I don't know, Lopez Mateos, Periférico, and you have the Waze app, and the Waze app tell you that is you need to change line because there is an accident a few miles away, so you can prevent the accident and give a more fluent traffic in you can sorry, I need to reformulate. The Waze tell you in advance to change line so you can avoid the accident, and this in a feature like your car, for example, not only the app can suggest those actions, but nowadays the Waze inputs are manual and not accurate enough to tell us the line of the road. For example, you can have in advance that there is an accident ahead, but you can't know the line, so can there is no possible way right now to solve this problem, but we are going to talk about the vehicular edge computing that could be a possibility in the near future to solve these kind of problems. So connected vehicles are vehicles that provide bi-directional communication. For example, in the case of Mexico, the cars are only receiving information, but they are not sending any information to the OEMs, the producers of the cars, the brands of the cars, like Toyota, Mercedes, I don't know. And there's an estimation in the paper that was made in 2018 that there is going to be in 2020 250 million vehicles, connected vehicles. But in the reality, in 2022, there are only 150 million connected vehicles. That was because the pandemic, all the producers downsized the production of the cars, but there is still a huge amount of connected vehicles right now, and for example, in only the US, there are a lot of connected vehicles. So to connect these vehicles, there exist vehicular networks. So they provide, for example, safety, shared road conditions, accidents, ease of driving and convenience. For example, traffic lights synchronization, entertainment, greater efficiency through sharing the useful information like weather conditions, and fuel energy savings because of traffic light synchronization and many other useful tools for the roads. Vehicular networks right now face huge challenges to meet the requirements in terms of storage and communication. There's an estimation, and I think is an Intel estimation that a smart car needs to process 1 gigabyte per second to make decisions. So, for example, we talk about in previous classes about those kind of example because you need a real time velocities to process all the information. Right now, not even 5G can process and send and process and give back to the car that huge amount of data. So, for example, you have a reaction time of 1 second. It will took you if you are driving at 50 kilometers per hour, so you have an average of reaction time of 1 second. This is an average. You have only 13.9 meters of reaction distance to the hazard. So there is a lot of there is a very long time to prevent an accident. So the information needs to travel and be processed in a very fast way. Vehicular edge computing, it's trying to solve these kind of problems because of the benefits of the edge computing. This is very similar to other topics in edge computing. The vehicular, it's the only difference is the vehicle itself, and there's a comparison table comparing the vehicular edge computing and the right now the vehicular cloud computing. So, for example, the location of the edges, it's close to the users, and we all know about the particularities of the vehicular cloud, the cloud computing itself. There is a remote location, there is a high latency, there is a limited mobility support, and for example, decision making could be local in the edge node and the communication between edge and vehicle, and for the cloud, do the resources for the computational resources. You have a less amount of time to process that data, but the limitation is the latency. So the decision making needs to be in the edge, in the local, and in the vehicular cloud computer needs to be remote. And communication could be real time, and this is a constraint in the place. There is a lot of constraints in the bandwidth and other particularities that we already know. For example, the computing capability of the edges could be limited, and is the cost of development could be more affordable for the edges, and for the cloud computing, it's going to be always high. We are going to all these topics, but in a very short way. The architecture of the vehicular edge computing, the smart vehicle, and the issues of implement that architecture in the roads right now. The architecture it's composed by 3 layers. Cloud layer, it's a centralized cloud. We already know all the capabilities, and an edge cloud layer. It's composed by a SDN controller. An SDN is a software-defined networking controller, and the edge nodes are composed by RSU components. There are roadside units, and it can be exchange data with those vehicles in range. And another basis, microbase, is the SMBS. It's a microbase and works under supervision of SC, and SC is in SD controller, the central intelligence of the port, and is the master orchestration of the resources and communication of all the node edge. So there's communication between cars to cars, and cars to edges. We are going to talk about in a second, and could be implemented in networks already deployed. For example, 4G, 5G. There's the connection between could be the connection to the cars to the edge cloud layer, and for example, the communication between cars to cars could be a LTE. It's 4G, but some modifications for vehicular communication. LTE-V is the name of the network. In the edge cloud layer, ensures the connection between the smart vehicles and the cloud layer. So there is an edge composed by different components, as we already see, and also provides communication in 2 different ways: vehicles to vehicles, V2V, and vehicles to infrastructure, and it's V2I. And for example, example of use, it's monitor and share strange behavior of other cars. For example, a change of direction, a violation of the speed limit, mechanical failure, emergency messages. For example, an ambulance approaching for in the lane that you are going, or take measures, and in advance took that measures, for example. Service provided by these layers are infotainment as a service. It provides useful information to the users about the events like emergency situations connected to the vehicle connected to the vehicle cloud layer, and also offers entertainment services like music, games, movies, and so on. And network as a service use the car as a modem to share internet connection. Storage as a service, for example, making backups for a temporary purpose. For example, you are collecting a lot of data, and you can download that data to the edges and not wait for a stable communication to share that data with the producer of the car. And computation service, for example, stop vehicles have unused computational resources that adds that we don't use that computational resource in the, for example, a parking lot. It's offer an alternative to use that computational resource. I don't know, maybe mining Bitcoin. I don't know. Use the computational resources of the car when is when the vehicle is stopped. For example, there are real application. The Horizon is in the company I work for, Continental. This application communicates with the car with satellites and other edge layers, edge nodes, to prevent. And for example, the example I was mentioning, have an eye in advance for example, an accident, or maybe a road condition dangerous. I don't know. These already exist. I don't know how many clients do have implemented, but it's already a product for Continental. And also there is still a new, I don't know how to say, network that it's being developed. It's the V2X. It's a vehicle to everything. So we already know that the vehicles can connect to other vehicles, and those vehicles to the edge, but can also communicate with other stuff. I don't know, maybe other pedestrians, or the infrastructure of the smart cities in the future. The smart vehicles, the characteristics to make this communication possible, you need a smart vehicle, and the characteristics are the capability of computing, has storage, communication facilities, many network abilities, and can learn from its environment and make decision accordingly. You have an we're going to see it. For example, many brands use LiDAR. It's like radar, but using light to map the environment in a 3D cloud in a 3D cloud surrounding. For example, 2D vision. This is used by, for example, Tesla to map all the environment, but in 2D. All the conversions to 3D are made in the car and also remotely in cloud computing. And the vehicle sensors. Right now, there is a huge amount of sensors in a car: tire pressures, cameras, rear camera, collision sensors, uh, wheel speed sensors, night vision, a lot of sensors that produce a huge amount of data, and that data needs to be transmitted to the OEM, to the brand of the car, to be processed and make autonomous vehicle possible. So we know there is a huge expectation of this technology. This is the most relevant service of a smart car, and there is also no infrastructure possible. So we are expecting in the 2030 to have a fully self-driving car, but it's very complicated for many reasons. Why? Because it's a long tail problem. So what is the meaning? For example, you have many common conditions in the in a normal day. For example, driving to your home, there is a lot of many type of cars, but all is recognizable, and the car can make the decisions to drive, to stop, to follow signs, traffic lights, but also we can challenge scenarios in which it's difficult to even a person to understand in the in a short moment. So it's complex for many artificial intelligence to comprehend many scenarios, and because they are not of every day, for example. So there is a it's a huge problem. So to make this possible, you need also the communication for the vehicle to share that scenarios with other cars and prevent and learn from those cases to understand the and prevent those future cases. For example, the smart vehicle application and the requirements of the data. And for example, health monitoring system. There is a, for example, you are driving your car and the steering wheel have a sensor of how do you say the blood pressure of the passengers, for example, and you can determine the health of the driver. So you need real time, because the passenger could having a stroke or another medical condition. So you need to prevent those actions in a real short moment. So, for example, in the data, all the source of that information are for example, the steering wheel sensors. And how many data do we need? Only some seconds. But there is a huge amount of application and different characteristics and requirements for make this application possible. Vehicle edge computing technical issues are the common ones. Latency, routing approach. Routing approach is how to we are going to talk about in a moment. Scheduling and load balancing, offloading of the resources, resource management, and also the security and privacy. Continue with that idea, the challenges. For example, the mobility. The mobility is all the environments, all the all the environment of the surrounding are always changing. Not a single car is the same, so you need to respond in a very short time to reconnect to other vehicles to have and share the information. Routing and forwarding, it's difficult to predict which vehicle is going to take its services from which one of the bases, station or edge servers. So you need to prevent the load balancing and the routing for those cars. For example, you have a huge amount of cars connected to only one antenna. You need to balance those charges in a very short time. Content catching, it's safe and forward info not requested. For example, emergency situations, and that another car it's putting on the edge, and the cars passing by this edge can acquire that information, and it's there is no policies to create the most effective temporal and spatial scope for those messages to share. So deployment of the network elements. This is the routing problem. How many nodes do we need, for example, for a smart city, and how many edges of the car do we need in the roads do we need for a full range of all the, for example, avenues and the streets. For example, Guadalajara, there is a huge amount of cars right now, so there is it needs a huge amount of investment. So those technology needs the infrastructure to be possible, but also needs to be cheap for the users and also the providers of the technology. And also, and maybe the more important, is the security and privacy, because you have an external communication of for your car. For example, each car can be traceable. So for GPS, every car can be traceable. And for example, the vehicle can monitor your state of health. So those data are private. So you need to only share that information with only the companies or the people allowed to use that information. And for example, is also exists OTA, over the air software updates. For example, needs to require a huge amount of security to provide software updates to a cars. So there is no possible way to introduce malicious software into the cars. But this application is right now used by many companies, for example, the US, to update the software of the vehicle. And the conclusion is, doesn't matter how smart your car is, if there is no collaboration with the environment, other cars or the nodes, there will be no improvement in the transportation in the smart cities. So you need you need the collaboration of the teamwork with other cars and the environment to make a possible and smart transportation in a near future. So that's all for my part. And questions? The discussion leader is Ricardo Rey.
Thank you, David, for the presentation. It was a good summary of basically challenges of transportation in smart cities, right? Who's leading the discussion?
I am.
Okay, go ahead.
Yeah, cool. Yeah, so essentially this edge stuff is like a intermediate point between the cars and like a bigger cloud, right? So this introduces another point of security concerns. So my question here is, what would be the implications of a breach in the edge cloud database? So for instance, maybe this cloud database at some point, this edge database, sorry, at some point someone comes up with an application in Tesla or whatever, that given my usual routes, like optimizes it knows I go from A to B pretty much every day. So it optimizes that route, right? But it needs to have some historical data. So it has a database that has some information of mine, and like the routes that I take daily are pretty sensitive. So what happens if, for instance, like some bad people take a hold of that, right, and know my daily routines, like they know the times and dates at which I'm leaving, or maybe an insurance company figures out that I go really frequently to a doctor and decides to increase my premium rate, right? Or like even worse, right? Like what happens if someone is tailing me and somehow is picking up information from my car, right? So this car essentially now is broadcasting information, right? And some of it's being stored in databases, some of it like might be just like communicated to other cars, but there seem to be some security implications. So what do you guys think about it? Like, should we be scared of a future where my car is talking to a database and a lot of cars, or can we rest easy at night?
Yeah, I'm willing to hear everyone's opinion. Is the future scary or interesting, basically? in this context.
I think
What do you
it's
think?
scary, right? Because every time you share information with
any service or company, for some reason it gets leaked or it gets hacked. And in more like it's more common here at Mexico, like the INE, I don't know how many times it has been sold or hacked or put on servers that are freely available to anyone. So I think it's kind of scary because, well, you don't know who is going to get all that information, right?
Yeah, and like I personally just like keep the Bluetooth in my phone off, right? Like I don't want it like connecting to other people. But then if my car is connecting to like the other 100 cars in Lopez Mateos, then like what kind of information are they getting out of me, right?
Yeah, I guess there are like two different ways to see it. Right? I mean, one is that us being attacked as sniffed. I mean, as getting data without us knowing at all. That one will always happen. They always find a way. If they want to, they'll get it, right? But the other one is that I do believe that we need stronger guarantees and legislation regarding data that because of some reason has become available. I mean, whenever data becomes available and it is publicly accessible, it sometimes, I mean, most places think that they can already start exploiting that information. So we need some stronger ways for companies or for legislation level for even though this information is available, it can be used that easily, right? I mean, like some stronger tracing process so that we know where they are getting their information. And even if that source is public, it shouldn't be used that easily. Right?
I think that's not the worst of the cases. I think the worst case, for example, is that someone is doing something malicious in your car, right?
Yeah.
I mean, information. Yeah, I mean, all information is valuable, but in this case, imagine that you are driving and suddenly the car start behaving like strange. That's very dangerous, actually. Like yesterday, my neighbor, the one that is near my home, someone cloned the key, and they try to steal the car. They just open the windows. But yeah, definitely that's something dangerous, and I don't think that's sharing your information with other cars is, well, you need to, like you said, you need to have some guarantee that your information is very secure, but I don't think they will have like that.
Or that it becomes like anonymous, right? So they cannot link that information to you. That could make it safer.
But in the example Ricardo was mentioning, that if he's really having a frequent visit to the doctor, definitely like insurance companies, even the car insurance company, they want to know that, right? So in that particular example, for example, that particular scenario, yeah, anonymizing wouldn't be something, how to say, something desirable for some people, of course, for those that can benefit. But anyway, as David mentioned in the presentation, no matter how smart the cars get, if they don't get connected until everything is get connected, and basically we don't get to that optimum level of traffic management and smart mobility. Basically, to get to there shouldn't be basically anyone driving their own car, right? That's also a very interesting way to look at it. I mean, as long as there are people driving, we can get to that high efficiency of high smart mobility because people are unpredictable, right?
As Antonio says, I think the intention of this technology and B2B communication, vehicle to vehicle communication, it's all the network acts like a swarm or enjambre or something like that. You don't need the ID of the person driving. You only need the information of the traffic, of the weather conditions in a few miles ahead in your road. So there is no need to couple the driver to the information, for example. For those cases, the vehicle-to-vehicle communication.
And the thing you mentioned in that figure, and you were showing that there is a long tail problem, that's really interesting. I think a lot of people missed that when they were predicting we get to full self-driving mode so soon, right? I mean, there was like, if you go 2 years back, there were claims really, like even by Elon Musk, that we get to that point very early. But they basically, exactly, I think they really forgot that long tail problem, that there are certain scenarios that it get really, really complicated to solve that. But I mean, usually without those problems, like normal cases, as you said, most of the times it's uneventful, right? It's normal. But there are those rare, really rare cases that make it extremely difficult really to get to that full safe self-driving mode. That was
yes. Tesla is trying to solve this using simulators. They share in the conference Tesla AI Day. They are using simulations for train those situations, strange situations. People in running in the highway, dinosaurs are in the streets, on something like really weird cases that you cannot reproduce in real life. You only could reproduce them in a simulator, for example.
Cool. So if no one's going to, does anyone have anything else to add for question 1? Or should we jump to question 2?
Yeah, I think you can go ahead.
Okay, cool. Yeah, so this is about this B2B communication thing. Like what David was just saying, that the idea is having like a swarm, right? And it is a well-known thing that one of the reasons that traffic gets bad is because of reaction time, right? Like the light turns green and you see it turns green, and like 10 seconds later, you're still at a stop, right? Because the idiots in front of you are not moving forward. If there was a computer that could coordinate them all to move at the exact same time, at the exact same speed, then like that would be way better, right? So having this swarm where all the cars are talking to each other is sounds like a great way to solve some of these like traffic problems and like the safety, all that stuff. But then like this essentially turns our streets into a distributed system, right? Like every car is talking about every with every other car. So what happens in the case of some sort of like network partition, like some subset of cars for some reason cannot, like some group A of cars suddenly do not see group B of cars? What happens in this case? Like, would it even happen something like this? Like, I mean, maybe they're not talking directly, right? Like maybe they're going through to like some antenna that then routes them. So I think it is relatively possible, right, for something like a network partition to happen. So what then? Like, do you have two swarms that are not cooperating and then like chaos will ensue, or is this not a possibility because of how they are going to be talking to each other? Like, what do you guys think? Like, I guess the question is, do we see some of the same problems that we have in distributed systems in this swarm of vehicles that are talking to each other?
I think that in that case, there should be, or there must be another security mechanisms not only the main one. For example, you're talking about remote control, but I think we can have a local also security like mechanisms. For example, the ones that we have right now, cameras and sensors, but that for example, if you have two cars, one in front of you and one in the rear side, in a local way, you can have this security like locker that the car doesn't allow you to get closer than a certain distance of the car in the front, and also from the car in the back side. Maybe it can have, or it should have the same kind of mechanisms, because you can't only trust in a remote way of control. So I think that kind of perspectives should be taken into account.
I think if you consider a city, I mean, if you're talking on network partitioning in a like city among the cars, I see that very low possibility that can happen. But because again, cars talking to cars and cars talking to other cars, right? If there is a group disconnected from other groups, anyway, any of those groups that can connect with any other groups, they can maintain the communication. And I think, for example, yeah, as Paul was saying, there can be certain mechanism like basically internal mechanism in each car that if there is any problem, they can basically separate themselves from the network. They can go to a safe place. I mean, it's a safe zone, you know, hiding themselves, pulling over or a certain part that can be designated for this type of scenario. Another thing that you were saying about red lights in a 100% basically self driving mode that every car is automatically driving, we don't need traffic light.
Mm-hmm. Yeah, like if we can achieve perfect coordination between every individual in the swarm, then yeah, traffic lights are a thing of the past.
Yeah,
I mean,
but like if at least one car gets disconnected from the rest of the network, like the network car just like blew in flames, whatever. Like that car now is a liability, right? Like now it's dangerous because it's not speaking with the rest of the swarm. So like I mean, in a distributed system, one node goes down, like that you need to detect it and like you take some corrective measures. But like the rest of the network takes corrective measures, right? The rest of the system, sorry. But in here, like what do you even do, right? Like you now have a rogue car who is not following all the rules. So like if you actually go and go ahead and say traffic lights are not needed anymore, then what does this guy do, right? Like is he stranded until he fixes his car? Like I don't know. I think it's an interesting problem to solve.
Yeah, I mean, the way I see it, in that type of scenario, in that board, you are not allowed to drive. I mean, if you get disconnected, the car is out of network. Basically, the car should be basically, to me, I mean, based on my understanding, the car should basically stop wherever it is.
Mm-hmm.
And that would be the best scenario, best solution.
But that sounds like a very engineer solution, right? Like if you start getting people talking about the right to move around in their city because they do have a car, it's just like slightly broken, but like the wheels are working, the engine is working. Like why shouldn't they have the right to keep moving, right? So I don't know. Like it gets in a funny intersection between like solving the engineering problem and then actually getting people happy with the solution, right? Which I don't know if that intersection exists.
Yeah, I mean, I was thinking just about this movie, the one I, Robot, Yo Robot, in which he basically, I mean, if you see their highways, their cars are like moved automatically, but their highways are designed the way they want it, right? So basically they created an environment for it to work perfectly. And in just a single moment when he lost control, it was just a mess. I mean, he started like crashing with every single car and so on. I mean, I think that probably we should be thinking more on how to change cities for this to work too, right? I mean, because as we were saying in this long curve that we were showing just a bit a second ago, I mean, there are tons of events that we can control, right? Because of the way things are currently. But if we can get into a place where we can actually control these events, like in this utopic place where all the highways are underground, so it would work perfectly, right? Because we would manage to get rid of all of these events. But yeah.
Yep. Cool. Yeah, and along kind of the same lines, like my question too was about my car getting disconnected from like the other cars. But then like let's say that in order for my car's autopilot to work, it also kind of like needs to speak with some edge server, right? And if for some reason the communication is low, right, like packets are dropped, whatever, like networks are unreliable, what happens then? Like again, do we just like say, oh no, you cannot, like let me just freeze you here and nobody will around you, like everyone around you will just like avoid you, like as though you're the plague, and you're like completely stuck if you cannot get like the routing directions? Or I mean, it's just kind of like a follow-up, like if there's not a network partition, but like packets drop, just like slow communication, I think it's kind of the same problem, right? Like as long as we have things, like if we assume that the swarm is completely interconnected, then things are dandy and it works fine. But the moment things start failing, and like in big environments, failures are kind of the norm, right? Like if you have like a couple hundred cars, then probably the probability of things failing throughout the day is like pretty non-negligible. Yeah, so it was just a little bit of a follow-up. Like I don't know if someone has anything to add there, or if we are done.
Yeah, maybe we can wrap this up so we can basically get to the other presentation. Thank you, David. Thank you, Ricardo.
Sure.
Let's have like a 6 minutes break. We come back it's 5 minutes. We come back 8:15, and we continue because we are still having 2 presentations. So I want to have sufficient time for that. So we come back 8:15.
Okay, thank you.
Okay.
Hey, hello, can you hear me? Hi.
Yes, we can.
Yes.
Yeah,
Okay. It's because I was talking before and I realized that I was muted. So, okay, my paper was, well, it's about infrastructure as code. And, well, okay, what's the paper about? It's a research project from the Department of Defense, the United States Department of Defense. And it was done by the Software Engineering Institute of Carnegie Mellon University. I don't know if anybody knows that university, but it's popular here because of computer science in the United States. And they wanted to check the feasibility of infrastructure as a code, the usage of infrastructure as a code with the Department of Defense, summarizing the problem addressed by the research and, well, the approach and all the results. So on this paper, well, they have most like half of the paper. It describes the steps about how the system that they build works, but I will try to focus mainly on the on the characteristics of infrastructure as code, because I think that that's more important than in how they did their research. So from the research, I summarize like the more important things from infrastructure as a code, how it works, the advantages and disadvantages. Well, I didn't put the disadvantage actually. But well, what is infrastructure as code? Infrastructure as code, that it's also IAC, is a set of practices that uses like the code for setting up virtual machines, like instances, installing packages, making all the configuration from a web system, or yeah, like, and all this system is written as it is described as code. You know, instead of using like all the GUI, graphical user interface tools that a lot of cloud providers provide. And well, by using infrastructure as code, it can be developed and managed in the same process as other type of software, any other type of application that you submit, like for example, to repositories and things like that. And for example, it can be also, well, you can create test cases against the code, and you can version control the code and store it in different repositories like GitHub, Gerrit, like, well, any type of repository that you want to use. So a little of history, let's say. So infrastructure as a code and well, the practices emerged because of the introduction of cloud computing. And especially when they start building infrastructure as a service, that they start providing some services so you can build your services by using the console. So as I mentioned before, while some cloud providers, cloud service providers give you like the console access on the top of the, well, yeah, in a graphical user interface, it is not really practical because well, it's time consuming. Also, you cannot have like the complete insight of what you are doing because you are focusing component by component. And also, if you want to reproduce like in again in different regions, clusters, or things like that, it's difficult to handle. One of the examples of this that I'm mentioning is like, for example, right now I'm going to use Amazon Web Services as an example. And for example, if you want to create, like, for example, an EC2 instance or a small application, you will have to do like several steps and to fulfill like several forms. So you can run like an EC2 instance, for example, or some other web service. Like, for example, first you would have like, for example, to log to the console. Then the next step would be, I don't know if you see my mouse, but I hope you see it. But then, okay, that's good. The next step would be, for example, looking for what type of service you want to use. So here is like, for example, at least 2 steps. Then when you want to, in the dashboard, you have to create like launch instance or create instance. And then after that, you have to select which type of instance it is. And then you go to a different page. And also between pages, you have lagging. And then that you have to fulfill a lot of fields there instead of only focusing on the ones that you are interested in. And then like adding storage devices, configuring security groups, and then creating a, how you say, key pair keys, a key pair, I'm sorry, so you can like log into the console. So at least here, and this is one small, are like 8 different, how you say, screens that you have to use using the console. And if you do it by code, let's say if you use Amazon CDK, that it's called a Cloud Development Kit. No, yes, Cloud Development Kit. You can also say store the same, and you could use like in 74 lines of code, you can do a similar thing, you know, by creating something that is called a VPC or VPI, by that it means virtual private cloud or virtual private instance, you know, in other type of, how you say, definitions from different providers. You know, you can create the security groups, but you can focus only on the rules that you want to focus on instead of having like a super big list there of options. And then you can create also for the security group, well, roles. And then the important part that it's the creating the EC2 instance. And for example, creating the EC2 instance is from line 52 to line 67. If you want to do some create a second instance by doing it on the GUI. Actually, you would need like to create the same steps as before. And if you want to do it by code, you only have to copy almost lines between 52 and 67. So it's adding a little more code instead of having the entire process again. So what does infrastructure as a code enable? Well, the most obvious capability is that it enables the automated configuration and deployment of the systems and software into an environment. And well, this will increase efficiency and provides repeatability. As I mentioned, well, you have usually the infrastructure as a code that are like how you want your infrastructure to be done. And you have also the configuration files that it's like all the properties on how each web service, let's call it, is going to have the configuration of from each service. And also you have to focus, you can focus only on the properties that you want to enable. So as we mentioned before, so all the infrastructure is written in code. And you can have a version control repository on it. Like you can put it, as I mentioned, in Gerrit, OneGate, or whatever. And the nice thing about it is that you can create, like, for example, different versions, different branches, different whatever, and you can have different deployments, right? Also, you can automate those deployments by automating, instead of calling so many APIs, you can create some code to modify the code automatically, for example, with a pull request or a pull well, not a push request, it's on Gerrit, but committing a CL that it's on Git. And you can automate that and also automatically trigger a process that creates a new, how you say, a new, well, it can launch a cluster of a service or whatever, so you can test against with the changes of your code. As I mentioned before, like, for example, the user here, like, writes the code, then you have all your code in the infrastructure. And in the infrastructure, since you are having a version control tool, you have different chassis, or you can add like your own version if you want, and you can have differences, right? And then you can push the code to a server, and the server will manage automatically your main, for example, if you say the main branch, it will be your main repository or your master, whatever you want to call it. And then if you have forks, or, well, if you have branches from it, then you can start creating a like on-demand or on-premise, how you say, instances. Also, something that it's really nice about it is that, well, it manages the auto-destroying, like, of previous, how you say, components and things like that when there is a difference in the infrastructure. And also, the thing is that it makes easy to roll back, right? Because if you are doing it from the GUI, imagine, like, you have to have the configuration. There is an issue, and if you forgot one step of configuration of rolling back, or you don't know how to roll back because most of the times you have to execute the steps in the inverse order, then you would have a problem, right? And if you have like infrastructure as a code, you can only select the previous version, like do a, how you say, git revert or something like that, and you can go back to a previous one, or git checkout to a previous version and do it from there, right? You can go, and also something that you can see is like between, let's say, 5 different versions, you can see how much the code changed, and you can see the changes, right? Like from one day to another and things like that, instead of having it in the console, that it would be more difficult. So there is a relationship like between the, how you say, infrastructure as code, IAC, agile, the agile, how you say, concept, well, and paradigm, and the DevOps. I will mention what is agile and DevOps in case somebody doesn't remember or knows. Well, the agile, it's a set of practices, you know, and one of those most important practices, it means that we should have working software, and we should be able to respond to changes. And how you say, by automating the creation of an execution of environments automatically, we can, how you say, we can work with these two, right? With working software and responding to change. Also, because the IAC, since you can create test cases against the code, you can be more assured that it's a working software. And DevOps comes from the term development and operations processes. That the main goal is to reduce the time between committing a change. Committing a change, you know, is like pushing a change to a system, and the change being placed into the production, right? So it's like how fast you can reflect pushing a change to the repository, and how fast the infrastructure changes, right? While ensuring high quality, continuous integration and continuous delivery. And what else? So yeah, as I mentioned, the automation of deployment can reduce the cycle time and improves the quality of time by delivery because it's automated. And that's all from here. So only as a reminder, like, because some people could get confused with Agile and Scrum. Agile is the philosophy on how successfully you deliver software to a customer, but Scrum is a methodology. So you have steps, you know, it's like the process. Well, a methodology, it's almost a process. But so infrastructure as a code is not like part of that, but it overlaps on those, you know. So as you can see, like infrastructure as a code, it gets a part of continuous CI/CD, of DevOps and Agile, but it's also even more. So infrastructure as a code, well, we have also something called configuration management, and we have the infrastructure as a code. And infrastructure as a code are the, how you say, the tools that manage how your infrastructure is going to be built and how it looks. Some examples of that are Terraform, Pulumi, CloudFormation, Google Cloud Deployment Manager, Azure, and there was another that it starts with A that I forgot. No, and it starts with V, but I forgot the name. On a Vagrant, I think it's called. And then the configuration management as a code are like Puppet, Ansible, SaltStack, Chef. These are the main ones actually that the paper mentions. And we have, I added here, the Amazon CDK. This is not configuration management nor infrastructure as a code, but this is like a set of tools that actually helps a lot with both. You know, because with the AWS, you can write the code as if you were, you can use, first of all, you can select a programming language that it can be TypeScript, JavaScript, Python, like, and others. I don't remember how many. Actually, C++, I think that it's new. And then what it happens, it will create, you can create a code for Puppet, for example, or Ansible code, you know, from there. And then when you compile this, it can create a Terraform or CloudFormation or whatever templates at the end. So it's like an entire suite of tools that you can use. But usually AWS, whatever, well, if you use the native and you are not using some stacks from other configuration management tools, directly it creates a CloudFormation, and if you want, the Terraform, and make the deployments like super directly. Sadly, I like it a lot. But then, okay, well, those were some definitions and some of the main concepts from infrastructure as a code and more or less how it works. I didn't show, well, something that I forgot to mention about this is that some of them they have different representations or schemas, let's say. Some of them, for example, can use like Ruby on Rails. Some of them are in the form of JSONnet or JSON format. Some of them are in the JSON of YAML files. I hope everybody knows all these formats because I can put pictures of it. So there are like different representations that you can use like the infrastructure as a code. And there are some others like tools that you have, but are not like really popular, that also use like other type of languages. So now again, like from the paper, the relationship from infrastructure as a code and the Department of Defense, they want a software. Well, the project is about having software sustainment. So it's like how you that means that all the processes, procedures, people, material, information are required to maintain and operate the software aspects of a system. And this is what Carnegie Mellon University like helped to the Department of Defense, and this is the research projects about. And what they mention is that well, the infrastructure as a code gives you like a safety net. Why? Because one, you can create, like as I mentioned, like test cases against it. Also, it's much easier to have like create diagrams from code rather than from all the console. So you can try to make you can compare some architecture from the implemented infrastructure. So what is going to be the design and what's like actually there. Also, you can perform like several experiments and roll back that, and knowing clearly which, for example, instance have which change, and compare instances at the same time. So and then for example, as I mentioned, like, I'm sorry, I'm going back. The goal of the Software Engineering Institute of Carnegie Mellon University is to try to, how do you say, to integrate infrastructure as a code to the Department of Defense. So what approach they follow and what approach do they follow for this research is that they created a system, actually, like they created code and application, let's say, that when they have like an application, a web system, they can recover deployed architecture. So if the architecture, let's say, was done on AWS, how do you say, they could like ping or get access to several of the nodes and try to reproduce what's the architecture of that web system. So this application creates a, how do you say, infrastructure as a code script. So as I mentioned, the approach consists of developing a prototype tools to inventory the system computing nodes, and they apply heuristic rules to make sense of the inventory. And what is heuristic? Because in case somebody doesn't know, it's like the approach of solving a problem while learning or discovery that employs a practical method. It doesn't warrant like that it's like the optimal approach or that it's perfect, that it doesn't contain errors always, that it's logical, but it's like an approach that makes sense and is sufficient enough to reaching an immediate goal, right? Because sometimes we want to solve a problem and we say like, okay, we don't want like the best route, but we want a super good route, right? Like that's what Google Maps does, for example, when driving. So they apply a heuristic approach, so the system can create the infrastructure as a code from an already deployed web system. So how does this work? So they have like the original system, and they have like different pieces that I will not explain a lot. I will not go into deep on how more or less it works, and also they don't detail in the paper exactly all the implementation. But one of the part is like crawl and inspect, that they are connecting to a node, a Bastion job, well, a Bastion node that I will explain later what it is, and they will try to connect to all the nodes that are reachable, and then they will start gathering data from all the systems, like checking the file system and things like that, and they will create a database that they call it inventory, where they will say like, okay, all these are the paths. Then I will check all the logs, and I will check how you say, which packages they installed at the beginning on that system. Okay, which databases do they have, and blah blah blah. So they will gather all that information, put it in the database. Then the analyzer will like try to, how you say, read all that information and make the analysis, and then they will try to, well, with the recovered and the generator, they will try to create the model, the infrastructure as a code model. So after that, the infrastructure as a code that it was the output from, this is the code that the Carnegie Mellon students, PhD students created. They will try to deploy it, in a copy of their own system. And they have a set of tests that they will execute between the original running system and the copy of it, to try to ensure that it has the same behavior. So one of the heuristics from this approach that they follow is that they create, well, the first heuristic, it's zero heuristic, it's in creating the target system. We care only about executable files on the source system, and about the files that are executable files depends on. So they don't grab like any files generated later, like logs, images, or audio, that if a system only the main system files. So, well, they created a process trying to get that, right? Then they use the second heuristic, is that they use the package installation history from the package manager. So they can know exactly what are the packages that it has to be, they have to be installed on each node. So that's how they generated the infrastructure as a code, like run scripts, or configuration scripts. Then the heuristic 2 is many Linux configuration files from common services have regular structures. Within a configuration file, we can identify entries that specify directories, and those directories contain content files. I'm not really sure, I don't remember about this really well. I only remember that actually they were using Linux systems mainly. That was one of the assumptions, and that they were where any file it's like an object. And the heuristic 3 is executables are started either by service manager or by an interactive user. So to trigger an application or a service or an executable, it can be only by the service manager or interactive user, and they will getting the checking the logs from this. Of course, all these things are automated, right? Then there are two more heuristics. That one is the interactive users will often set their path environment variable to include their executables that they run. So that way they identify also what executables are the most important or are the base ones. The heuristic 5 for services like SSHD use the services conventions to identify content files. So the protocol that they created and the application, it's called, they call it DRAT, that it's the acronym from deployment recovery. Deployment recovery, it's because they have an already web system, and they are going to recover the infrastructure from it because it was not as infrastructure as a code. And automation technology. So they automate it later so they can reproduce the same environment. This would be nice to use it on Facebook, on Google, or something like that, right? So here is
I'll try to wrap it up. Okay, you're running out of time.
Yeah, almost. So this is a summary of the DRAT prototype. And well, it's almost the same, how you say, example. And how they connect to the nodes and virtual machines is through something called a bastion host. That it's important because it's like one of the nodes that it has access to the network, and it's the only way to get into the system and connect, let's say. So finalizing the research results, challenges, and conclusions is that the system was able to identify and create all the system nodes. They were able to recognize most of the packages from the systems that need to be installed, because they have some logs that probably they were installing other packages and they have different configurations depending of the node type. They were not able to implement the heuristic tree that identifies all the executables from the systems, because they have like some path. Well, they were executing directly some paths from some scripts. It was difficult to backtrack paths when adding new directories, because they have scripts that are extra paths. And how you say? And also they have challenge with authenticity and policy access between resources. But well, at the end, after all, there were more pros and cons, and they identified that all these can be solved. So they have demonstrated that automated generation of correct infrastructure as a code artifacts, it's feasible. So yeah, questions and answers. Or discussions.
Sorry for the interruption. I mean, we were running out of time.
Yeah, it's okay.
Had you ever find any disadvantage on the code infrastructure as a code?
Yes.
Which
so
one?
Just one. So the only one that I have discovered is that for proof of concepts usually takes longer, especially because the setup at the beginning, it can be a bit tedious sometimes, you know. But if you have want to develop a proof of concept, a lot of times it's easier through the console, because you don't have to deploy it in several regions. But apart from that, long term, I don't find that. Like, probably another disadvantage could be that people can copy it from you if they get access to your repository, and if you did it by console, it's difficult to copy.
Yeah, but if you're in a company, you don't need to worry about that, right?
No.
Yeah, it's not that big deal.
I did have a problem back with Yak, and the problem was that if you have both, that is the management console and also Yak, you can have people going into both of them, and if for some reason they modify directly in the management console, it doesn't get reflected in the Yak. So
yeah.
At the end, you end up like messing the stuff. I mean, you can either like disable console for everyone or just everyone uses console and that's it, because otherwise you get a lot of discrepancies and like all the information stacks.
But in this case, I think you need to have like these best guidelines. So if anyone needs to do something by console, they can inform the person that is in charge of the files, and then they can do that, right? Yeah.
Yeah. And actually, something that you're mentioning about the console, something important is that on the web services, a lot of times you have different tooling, like for example, in AWS, to access each type of service, but this is not related to infrastructure as a code, right? Well, it's not like about your topic, but I want to mention so people don't get confused that, for example, you have tools for AWS S3, you know, or for the E2 instance or things like that, to access them, modify them, and things like that, interact with them. But infrastructure as a code, as we mentioned, it's if you want, you can do the same changes, but by changing code, compiling, let's say, and deploying, right? And those are like a code that you can see. But if you modify of course, something that by console, it will remain, unless you have like another system like Argo CD or Kubernetes or whatever you want, that it will detect an anomaly or a change, and it will try to recover, right? Yeah, just as comments. But yeah, like the only downside that I have found is if it's the first time that you're configuring something and you don't have like access to some service, it's faster to create a proof of concept by scratch by console. Always that it's a small application.
Well, and I think but that's a normally common disadvantage in all this kind of stuff is that, well, actually people needs to know how to code, right? Because it's not the same like someone that is going to use the
Actually-
console, that someone that needs to code in these files.
Yes, that's another disadvantage actually, that you need the language to learn how to code in that specific language. And some of the languages actually, like depending on which type of deployment, you have to learn, well, sometimes there is not compatibility. There are some tools that can convert from one to another sometimes, but not accurate always. But, and if you type in some, for example, you use one technology and you want to deploy to a different provider that is not like super big, probably they don't handle that, right?
Yeah, and also it's easier to make mistakes.
Yeah, way easier.
Where? In which part?
But the thing is that if you have Yak and you do have like a CI/CD very well set up, and you have like a process of actually going and reviewing the PRs before they get there, you get more reviews before you make a mistake, right?
But
Yeah.
what is Jack? What do you mean Jack?
What, sorry?
What do you mean Jack?
Yak. How Yak?
IAC. Okay, yeah.
Yeah,
Yeah,
It's in
sorry.
Spanish.
Yeah.
I was
Well,
like, I don't know what.
Yak.
Okay.
Sorry, I mean, sorry. I guess the correct one is AAC, but
Yes, IAC. That's why I was like, I don't know what is Jack. Actually,
Yeah,
well, okay.
he was talking in Spanish.
yeah, it's my,
Yeah, don't
the
worry.
best English that I have. Yeah, this is how I got into Cambridge, you know.
One minute story. So when I just came to the United States, the first week everybody was talking about the APIs, and I was like, I don't know what an API is, you know. And after a while, they said like, yes, API. Well, they wrote it, and I was like, API. It's
Yeah.
because I always in Spanish said API, and they were saying API, and for 1 week I didn't know what they were talking about.
That's
Okay.
quite interesting story. I don't know, Alejandra, you prepared any question or?
Anybody? I don't know who the person from questions was. I
Alejandra.
didn't
No,
know.
I think Alejandra's supposed to do, but I don't know if she's here.
No, it's not me.
Oh, no?
No.
It was you, right? Alejandra Holguin, it says.
In the file it says that it's you.
I didn't know. I didn't prepare any question.
Okay, no worries.
Sorry.
No worries.
Yeah, like, I don't know if anybody has questions. I hope it was clear. I think that it was a fun topic. That's why I selected it.
Yeah, it is. It was a fun topic actually. Well,
I
for
don't have
somebody
a-
that is doing some kind of DevOps like me, yeah, it was interesting.
And I think that it's useful. That's why I also wanted to select this one. Then if there is no more questions.
No, there is a question, Saul.
I don't. It's not a question. It's something fun about related with the Yak AIC. A few months ago, we were receiving some logs that our database was turning off all mornings, like the 3 a.m. And we spent a lot of weeks trying to figure out what was happening. We thought it was an issue with the server. Maybe we were running some job. It was misconfigured. So we spent a lot of time. So at the end, we discovered that we had a little file that was causing that error. It was Chef. Chef was running all nights and was looking for all applications that were installed in the server. And the Chef was configured to make unavailable some programs that it thought it were unupdated. So our database was in an old version, and all nights Chef was thinking that we were running in a insecure environment. So all nights our database was turning off. So at the end we have to configure the chef to avoid to process our database. And but yeah, we spent a lot of weeks trying to figure out what's happening there.
Trust failure as a service.
Yep.
Yeah, actually, something that I forgot to mention that in the paper they also mentioned is that the Department of Defense also wanted to achieve the goal of not updating the systems between months and years, because they usually took that time to update all the services, because they didn't have infrastructure as a code. And actually they have still all services, but the thing is that it's much easier also with infrastructure as a code, how you say, to update all the services, and they wanted to achieve it in days or weeks at most, instead of, and before it was between months and years.
The application, it's a little odd, right? I mean, I was thinking like, basically, if you go on into Wix or WordPress to create a web page, then you have like an artificial machine that determines like the HTML elements, and then from that you get the code. I mean, I think it was like a little over the place, right? In a little sense. I mean, why would you go on to like going that way instead of actually getting into the code? I mean, probably they don't want to get rid of their old behaviors of getting and doing things manually, right? I mean, it's kind of strange, I think.
I didn't understand. I understood the WordPress. That
I mean, imagine the scenario is basically if you go on and make a web page with Wix or WordPress, right? And you want to extract the code from there. So you have a system that goes on and scraps the web page, and from some heuristics determines which are the HTML elements. And then from that, it creates another web page that is a copy of that web page. But I mean, you could like get the code, right? I mean, I don't know. I felt that probably we need like more context on how the Department of Defense is keeping up the infrastructure, or why they really need this. Right?
Yeah.
Because I don't know.
Yeah, they don't go into details. It's
Yeah.
a public, and as also they don't go into details how the implementation was done. They only mention like at the top layer. Yeah, but it would be nice. Like,
let's wrap this presentation so we can have enough time to enjoy Fernanda's presentations. Yeah, the interesting part is coming up. Fernanda, you can go ahead.
Oh my God. Okay.
The expectations are high.
Why you put me that pressure?
I'm recording this.
Yeah.
I'm over recording.
yeah,
this.
everybody's going to record it now because
Yeah.
we know that Fernanda. We went like 2-hour presentation because those are cool.
I also have thesis and work, please.
The pressure is on.
Actually, I'm interested also in her thesis. Imagine that she makes an interactive thesis.
Yeah, that would be interesting.
I want to go there. I want to see that one, right?
Yeah, everybody.
Okay, go ahead.
Wait. Sorry, I'm missing my other screen. Do you are seeing my things correctly? What are you seeing right now?
Trust
You
the
can see
presentation,
trust.
I think.
Okay. Something that says trust,
Text.
right? Okay.
Yeah.
Trust.
Okay. The paper that I'm going to present you today, it's called Trust Mechanism for Cloud Computing. I love social topics applied to tech, basically because my background is about people. And maybe this reinforces the idea behind every computer, there is a person, always. So always remember that. Sorry if this is not a super technical topic, but it's still part of the technology world. So yeah, it's gonna be quick. I know my earbuds are getting low battery. Sorry, let me. You still hear me?
Yes, we can. Are we
Yeah.
good?
Okay. So I will give you some just a little bit of context of why I choose this paper. In my previous job, I was also in a group that has a very similar dynamic of this class. We used to read scientific papers in group and then present what we learned in front of everyone else. And something like the discussion group of like Wrecking Ralph or Alcoholics Anonymous, but with science, because we are good Christians, of course. But I remember that one of those topics that generated a lot of discussions was precisely this topic of trust. We ask ourselves like questions like, what is trust made of, and how can we build trust with people about our designs or about our products and systems? And I remember we end having a huge trip with this concept. But one of the most interesting conclusions we reached was that, in fact, what generates more trust is actually the human error. We agree that the trust we generate is proportional to the security of our own integrity, or more in simple words, making mistakes not only affects the client, but affects you, dummy. So technically, the client can be sure that you will take care of your product, because it's also going to affect you. Of course, these are not serious quotes. We're exploring like and trying to reach our own conclusion. But what is true and what is well proved, it's trust is not easy generated between humans and machines, because machines don't mind making mistakes. They don't fear to explode or harm people. I mean, do you think these have feelings or souls? I mean, this can kill you very easily without hesitate, but maybe yet. But again, all of this was just a discussion we have in my group, a trip we have. So what I'm telling you this, I just want to make you understand that this topic is very, very complex in a social way, very psychological in nature. And it's very easy to get lost and go in circles in this topic. And I think precisely for this reason, these authors of my paper made very clear that they're focusing more on the technical definition of trust than the social definition of trust. But please, this is very important. Not going in deep on the social aspect doesn't mean it's not important. And more than that, have present that people are not objects. We don't go through the same mental process to trust a person. I mean, as a person, we don't trust other person the same way we trust objects or things. And actually, we perceive companies like this non-facial entity. Obviously, companies behind are made of people, but we don't perceive them individually. We see companies like a sum of all these people, like say that we see these companies like the face of Microsoft, of the face of Oracle. But in this case, we will see it as a cloud service company. So now let's try to understand the main problem the authors of my paper were trying to frame. If you had to choose a doctor, how would you know whether trust him or not? Probably the more certificates, diplomas, recommendations, successful histories he or she has, the more we will trust they to be our doctor, right? Well, it's very similar of how we trust cloud service or cloud companies. As always, remember the user is our most important entity, and and when the user seeks to incorporate the cloud technologies in their company or project, he will look for a cloud service provider or representative. But how our user will trust to that company? Well, probably the cloud service will collect all the certifications, audits, testimonials, and he will start making promises to you like he's the best service between all the competitors, because insert here a graphic that probably they will have. But believe it or not, users have the most complicated part of all these processes of analyze and ponderate, because they have to ponderate or analyze, sorry, the repetition, all these promisers, certificates, proposals, testimonials, and compare all this information with their competitors. So all of this just to say yes or not to your offer. But the cloud service is much more complex than that. The cloud service is an entity made of many other areas, such as the auditors, the cloud brokers, the cloud providers, and obviously the cloud service itself. There are more areas, endless more areas like marketing, the business, a lot of different areas in the cloud service, but stick with those that are like the most basic one. And well, take in consideration that individually, all these organizations has to make, again, all these promisers, certification, evaluation for every single one. And probably you already are catching the idea of the problem. Basically, the user's job is not just to evaluate the cloud service alone, but the combination or the sum of all these papers or yes, demonstrations. And of course, that overwhelms the user. And well, basically, we want to convince them, and we only like toss all this paperwork and say, oh, I already did my homework. He will evaluate out of this. I'm not going to take in consideration what my user will try to do with that information, because we already did the very basic, I have to do 2 work, right? Yeah, that's basically all. That's the paper, all it's all about. They try to frame this problem. Probably you're taking, well, obviously they propose any kind of framework to do this in a more friendly way, but no, actually they just really focus on questioning this problem. And they even add an observation that companies normally put a lot of more effort in generate more of these certificates and promises, but they don't do anything really, or they don't do any effort to try to make something to, okay, I already did all this work. How can I show this easily? Or how can I not manipulate, of course, but how can I just like resume all of this information so my person can understand it well? They also even make like a, they even highlight another common mistake companies make, that is think that trust is just about the security or privacy of the data. But this is an unpopular fact. Products can be saved, products can be good, and people can still distrust them. People can still believe that they're not good because reasons. Sometimes we say that, but it's more than just reasons. It's about the trust. This kind of reminds me previous classes where we discussed that people don't buy products just because they are green or ecological. Well, here's the same. They just don't buy services just because they are secure or because they are cheap or because they have a nice logo. Trust is super complex to generate, and it is a combination of a lot of elements. The only thing that we can be extremely sure, and it's a fact, we only trust in what we can prove. And this is a very good advice. Just trust in what it's proved and try to really search how it was proved, not just in the data they are showing you. Well, okay, the paper really ends here, and I know it was very simple and very straight to the point. I don't want you to feel like I don't give you any like practical or any tool that you can apply to your projects or to your work. Previously, we say that cloud services have this, how to comply or gather all these papers, documentation, certificates, everything. But then how do you know what you need for your service? If you ever want to create a cloud service or want to incorporate a cloud service into your work or into your project, just remember that this is a very old data. I mean, old in tech time, because if this paper was made in 2015, and
explain by one all the contract certificates and marketing methods they use to generate this will be endless. So I better create these like frameworks or just like a checklist that you can have to, how can I say this? Like if you want to create a project and you want to incorporate a cloud service that have a cloud service provider, a cloud broker, and auditors, you can then check if they give you this information or yes, these papers, so you can know that probably they made their homework, but I still recommend you to analyze by one what they give you, what kind of promises are then making you. For example, the cloud service. Well, what is the cloud service? It's a combination of multiple things. It's in general or your organization. Just be sure that you as a cloud service has an identity. I mean, it's not just like the visual identity, but okay, you create a company that reflects performance, security, and privacy. Well, does that words relate to what you are giving to your users? It's more like how can I say this? It's hard to know how to do this, but probably that's the reason you found people from marketing that can make those words make seamless what you're giving to your user, sorry. You have to create compliance policies. These basically are policies and standards applying to the service. I mean, these are like literally contracts that you have to give to the users that you are basically telling them what you're doing and how you're doing and where you're doing those products or that service. You have to define your attributes. Like if your attribute is, I don't know, you are secure, for example, then how you are being secure. I mean, what are the techniques of security you are following to say that your company is secure? And then you have to define those attributes. You have to be self-assessment. Again, I'm not going to get in very deep in how to make this because really could be like a whole class by itself, but just remember that you have to give that or create those documents basically. You have to measure or more than, sorry, I forgot the word. You have to create verification and monitoring your processes. And you have to gather testimonials of what are you doing. And probably most important thing here, I will tell you, testimonials can be in two ways. You can describe, like clearly describe what are you doing without making promises. You are doing describe what are you doing. And the other, it's subjective and this where you are doing like a more social way, like, you know, like if you're selling, I don't know, fish in a market, probably you will encounter a person that will be very friendly to you and tell you that your company is amazing, like more human way. This is still not the best way. I recommend more the objective one, that it's just explain what you're doing in an objective way, but being subjective is also good in business. I mean, it's another way to generate trust. And I could like explain by one, but really they are very similar. They just want to get, probably later you can check this framework. It was made really quick of what I learned. This was made for me. And yes, as a cloud provider, you have to generate accreditations, complete policies, attributes, again, self-assessment, testimonials. Is very similar to each one of your product providers. Probably the most different one is the cloud auditor, because auditors are by itself a whole industry. And I don't even know how they work, because it was so funny that when I was reading the paper, auditors how be audited. So it's like a chain of the auditor audited another auditor. And I said, wow, who was the master first auditor that says the other auditor was good? It was funny, but that's how the world works right now. You have to get an auditor that audited you and an auditor that audited your auditor, if this makes sense. And we almost there. I just have another final like thought. Again, I know that this paper just was like the tech part, but what was the social definition of trust. And this is just like the end of this. I just want like to give you this little peek of what my past group have with this. How can I say this? So, sorry, rephrasing. I want to give you the social definition because it helped me understand better what is trust and how to apply and why the authors try to totally separate the definition in the social way than in the technical way. And just remember that trust divide in 3 factors. That is expectancy, willingness to take risks and belief. And something super funny, it's the only thing that we can control, because you cannot really control the trust in people, that the trust they give you to you. The only thing you can really like touch or try to do something to make people trust you is the part of belief. And because there is where you can create strategies to demonstrate your integrity or your goodwill. I mean, how can I say this? If I'm saying, I'm going to help you, I mean, that's just a goodwill, right? But then you prove your goodwill because you were helping that person constantly, or you were updating your system, or you were doing like more strategies that just say like, I'm gonna help you, like a goodwill. And your integrity, it's that. The integrity is like, I say that I'm going to help you, but actually I did something to help you. And I said you can only touch the belief part, because if you notice the other 2, the expectancy and willingness to take risk, really only depend to the user. The expectancy, well, the user will have the expectancy that you are good, right? You cannot change that. They will always trust you in the first place. Well, not always, but they always try to trust you in the first place. And willingness to take risk. Well, if you encounter a user that is not willing to take risk, I mean, they don't want to take risk, you cannot force them, you know? So those ones doesn't depend on you. The only thing that depends on you is the belief, or you can do something to reinforce the belief in you. And always based in evidence, of course. And again, remember, and this is the thing I really want to pass you, people are not objects, really. Don't try to combine what I told you about business with people, because you're gonna suffer really bad. And that's all. Thank you, guys. Sorry for the non-technical paper. And
thank you, Fernanda, for another interesting presentation. And I liked your approach, how you looked at it, and it's really interesting. Just in the paper, in the last part, when they were talking about future research, they mentioned this. I quote, they say future research will focus on mathematically formal framework for reasoning about trust, including modeling, language, and algorithm for computing trust. So given all this complexity you were talking about, trust, how one can think of mathematically coming up with a formal framework mathematically?
I always think that when they do a mathematical approach in this kind of social behaviors, they fall in the, how can I say this, in assumptions, or how can I say this, like, if the 90% of the people, how can I say this, lie to you, it's very probable that you will lie to me. And they try to predict things, but our predictions are better than showing you proofs in that moment. I don't know how to explain this really well. I try not to focus in the mathematical form, because probably it's gonna be about prediction. And here I want to focus more in what are companies giving you right now to do that thing. And it's something that is still work on, I think. So it's not still validating that mathematical framework they were talking about.
Go ahead with the last question.
Then I understand the question. Sorry, can you repeat?
Who's supposed to?
I am the
Huh.
the
Yeah,
person
yeah,
that
go
is-
ahead. Yeah.
Okay. I have 3 questions. Basically, they are a little bit more technical than what it was presented. So I hope everyone read the presentation. But basically, well, the presentation, as you say, is about trust on cloud computing. One of the points I said is that most of the time architects needs to, well, based on these trust mechanisms that are presented for selecting a cloud provider. So do you really think that the cloud architect is going to check all these trust mechanisms like ISOs, TARs, stars, and all of them that are there for selecting a cloud provider?
I do see that question. I don't remember if I create like a slide for that, but I remember that what I thought when I saw that question was, do you read when you install a program and it gives you like a whole list of promises and that kind of things, do you read them? I would say that question is, yes, you should. You should read those agreements. You should read those contracts. You should inform yourself to be sure to take the best decision about what you're incorporating in your company. The answer is yes, they should. And actually there are areas in companies that are just focusing on that to evaluate those contracts, but not everyone do that right now,
Okay.
probably, but they should.
Okay. In their own experience, anyone else, do you think they really read about the trust mechanisms, or they just choose one because that's the one? I mean, in my case, at Oracle, we don't have, we cannot choose. We need to use the one provided by the company. In this case, we have OCI. So if we want to use the cloud, well, we don't need to do this analysis about the trust mechanism because we don't have options. We just have OCI, and OCI is going to be. So what about the in their companies?
Actually, we evaluate a lot of that, especially the pricing. You know,
Okay.
but actually we check a lot of features that we want to develop, but a lot of times, how do you say, people have read, well, when we hire people, we hire people with experience because usually they have to be like at least principal engineering for taking those decisions or software architect, as you mentioned, you know. So they have to have some seniority, and by experience, we usually focus on several things. And as I mentioned, like performance, pricing, you know, and and compatibility with other frameworks sometimes. But yeah, we check like all the resources that they are displaying there most of the times, especially not only right now you're saying with cloud, right? But also with any tooling.
Okay.
We create like comparison tables a lot of times. Not only trust, actually, the ones that are there. From the main pages, we create our own.
Okay. So the second question is, well, we can see that there are a lot of mechanisms like I already say, ISOs and stars and all the kind of like more technical mechanisms. But we also have 2 mechanisms that are like more like personal. We have the interpersonal and we have the social one. So what do you think has more weight at the time that we are going to choose a cloud provider? Some technical mechanisms, or our own experience and the experience of people that is surrounding us?
So I have another one from there. It's mainly because I think that when you say, like, for example, the social ones, it's also like what most of the people use, right? And
well,
actually,
recommendations from friends, recommendation from colleagues, or some, or
yeah.
I don't know, when you are going sometimes to some presentations or readings, and you see that, oh, these people knows about, and he's recommending this specific cloud provider, so I'm going to take this one.
So a lot of times, actually, depending on who I am asking, actually, I use a lot of the social, because when I don't know the topic is when I ask, right? And when I know the topic, I only want a few more information, I research.
Oh,
So that like,
no, finish.
yeah, so as I mentioned, like, for example, if it's a new tool that it's like, okay, I'm asking other people, but if it's a tool that I already know, that I have used a few times and things like that, and like I have to compare it with other tools that I have also used, then I start researching actually what are like the specifics, right? But if there is one tool that I know and another tool that I don't know how to compare, well, actually, I start asking questions, and then I start from there. I start diving deep.
Okay. Anyone else?
Also, it's not binary. It's not like it's this or that. They take like combination of both. Like when you're searching for a job, they do take in consideration all your certificates and your bachelor and everything. But they also do call your peers and call the people you work with and ask them to talk about you. They use a combination of both the social and technical part.
Back in some of the startups I have worked at, there's like tons of social pressure on what programming language to use and which clouds to use. It is kind of strange. You like really understand it once you're like outside of that place. But many of those decisions are taken very fast. I mean, there's no time for making comparisons. And whenever like real trust concerns start appearing, you then go and say, oops, like just go on and patch it however way you can in the cloud, in the one you have, and the one you have credits with, and the one you have some like relationships up. So yeah, I mean, I think there's tons of social pressure, at least in that place.
Yeah, and adding to that social pressure, in the personal one, sometimes if you want to develop, select, you're the architect and want to select something, you usually go to the one that you know, right? Because you don't want to start learning a new one, right?
Yeah, of course. I mean, it's also better. I don't know how to say this in English, but it's mejor malo conocido que bueno por conocer.
Yeah. Okay. Just one last question. What do you think is the best combo of mechanisms for when selecting a cloud provider?
It really depends of the size of the company, because it really, the comment about companies make decisions really quick. What kind of companies? I mean, startups, they feel like they do really quick decisions. Where, for example, to release something in where I work right now, they took like 4 or 6 years to do something. So they take like precautions to not be sued for a lot of things. In this case, the same. You cannot contract or start adding like things to, I don't know, services to your big company just from one day to another, because if they lie to you, you will get into really hard, discussions. But in this case, it's a combination of all of them. Probably just be cautious and trusting facts, and have your own section in your company that will take care of all these papers they will give you, and try to validate them with the proper companies that they validate that kind of document. Sorry, I don't know every single one of them, but I know each one has their own like organization that validates those. And that's all.
Okay, that's all of my questions.
Okay, thank you. Thank you, Fernando. Thank you, Pedro.
You're welcome.
Everyone else who participated in the discussion. So yeah, that's it for today. We'll meet next week, same time. Okay.
Okay.
Have a nice night.
Okay.
You too, Mari. Thank you. Bye.
Thank you.
Bye.
Take care. Take care.
Bye.
Everyone.
Good
Bye.
night, everyone.
Bye.
Maria, I have a question. Can
Go
I
ahead.
talk to you?